Hello, my name is Carter, an engineering student. Today, I'll be chatting with Dr. Sophie Cox, a senior lecturer in healthcare technologies in the School of Chemical Engineering. More recently, her expertise has been called upon to improve the seal and fit of face masks in hospitals during the COVID-19 pandemic. Thank you for chatting with us today, Sophie.
Great to be here, Carter. Thanks for having me.
How have you coped with lockdown, and has there been any reading or have you been watching anything to get you through it?
Well, certainly my lockdown journey has had some ups and downs, but I think overall, as with most things in life, I try and take a positive mindset to its approach. I think routine's really been key for me, accepting that my old routine has kind of gone out the window and just trying to be flexible and kind to myself and adjust to the new lockdown ways of living. I'm not too much of a TV watcher, but certainly books, podcasts, yoga and meditation have kind of been my go-to things to help support my mental health really throughout the lockdown. And actually those are really interesting things that I talk about quite a lot with some of my personal tutees in the School of Chemical Engineering. So they're kind of skills that staff and students at the university, I think, are kind of calling on at the moment to make the most of the lockdown and try and find some positive experiences from it.
Brilliant. Thanks for that. Yeah, I've been lots of yoga myself. I find myself, after I've been crunching away at a laptop for so many hours, it's nice to stretch your back out. But yeah, as you said, we're all in lockdown and working from home. So is there anything you particularly missed about campus and the university?
Well, apart from old Joe and the beautiful green heart, which I'm sure has looked exceptionally lovely in the sunny weather and perhaps not so nice in the rain, but I think the thing I've missed most about campus are the impromptu conversations that we all get to have, whether that be with research colleagues in our Healthcare Technologies Institute, which often can lead to some really creative outcomes, realizing that we're both working on something similar and finding new ways to work together, or whether that be we've got a really lovely atrium within our School of Chemical Engineering, which is really the hub of the school. So it's a fantastic place where, you know, staff and students sit and eat their lunch. And yeah, it's nice to kind of bump into personal tutees or students that I teach and just have some impromptu conversations sometimes. So I think that's the thing that I've missed the most really about lockdown.
Yeah, I agree. I do miss bumping into my friends and just the campus. It's the sort of things you can't really recreate digitally. You like to use engineering to improve patients' lives, and your projects include mimicking our body's natural healing process using nanoparticles and creating medical implants using 3D printing machines. What inspired you to get into this area of research, and how did you get here?
So I think I've always been really fascinated with the way that things work, mostly because I break stuff and then I have to learn how to fix it really. So I think that kind of naturally led me towards maths and sciences. And I think I realised when I was initially applying for university that I really liked practical application of those subjects. So that led me to choose to study engineering. And it wasn't really until I kind of started the course that I grew a passion for healthcare, really. I think it's a great field to work in because the impact of it on society is very direct. And I think I'm both really focused on innovation, but also on impact on people's lives, really. I think that's what gives me a lot of purpose and a lot of satisfaction from the research and the teaching that I do. So that's kind of how I grew to be inspired by and want to be a biomedical engineer. What's kind of led me in the direction that I'm in now, being a lecturer in our School of Chemical Engineering, is that chemical engineering is so broad, and I think it's really a fantastic discipline to work within. We've got a lot of staff within the school that come from different disciplinary backgrounds, like myself. We've got some chemists, we've got some physicists, and then some more, core chemical engineers within the school. And I really love that environment of multidisciplinary working and teaching. And that's kind of what's led me to really love working in our school of chemical engineering, really.
Great, thank you for that. The COVID-19 pandemic has seen a huge increase in the use of PPE, or personal protective equipment, particularly for healthcare workers who have to wear it for a prolonged period. You've been using your research specialism to improve the seal on masks, which reduces exposure risk to the virus, as well as improves comfort. Could you tell us a little bit more about the work you've been doing in this area?
Yeah, absolutely. So what's been kind of quite prevalent, and what we've learned from clinical collaborators, is that PPE that's being used currently, because it's not typically used for such long periods of times, healthcare workers are struggling with some of the discomfort that the current face mask designs can bring. That they're having to wear them for their whole shifts and day in, day out. And I'm sure that many people have seen the images that have gone around social media and mainstream media of facial abrasions, bruising, etc. So at that point, we kind of put our heads together, and one of the kind of core focuses of our research team is making customized medical devices. So devices that are tailored to the anatomy of a patient, such that that device then offers a better fit to a device that is just a standard size. So at that point, we kind of had this initial thought around what value customization might be able to bring to PPE beyond the current standard mask, and to try and overcome that key challenge of comfort for the user, but then also making sure that the seal and the interface between the mask and the person's face is more effective, and therefore minimizes any risk of exposure. So we've been combining our expertise in 3D printing with a number of other disciplines, really. So the whole process starts with trying to generate a facial profile of a person's face. So we've been looking at several modalities, several different techniques to obtain that facial data, and comparing their accuracy and resolution. So you can scan a person's face with a number of apps that are available on smartphones. And we've been comparing those apps to quite high specification 3D cameras that are often available in clinical settings. And the good news is that the apps seem to do a pretty good job, even in comparison to the 3D cameras. So from that kind of 3D facial scan that we get of the person's face, we're extracting key parameters, so key lengths, as well as key profiles of the face that we know are particularly important to making sure that the mask will fit that person well. So people have different lengths of faces, widths, and also the nose area and around the chin are often particularly distinctive to a person's kind of facial anatomy. So we're looking at taking those facial scans, extracting those parameters, and then using those parameters to design what's called a CAD model, so a computer-aided design model. That then allows us to either fully customize the mask to the person's facial size and key features. But what we're also now looking into is the possibility of a semi-customized approach. So instead of it being an exact perfect fit to your face, we'll look at the numbers from those key parameters and then decide, are you a small, a medium, a large? Do you accurately fit within the kind of typical distributions that we see across patient profiles? And the big advantage of not having a fully customized approach, so something that's semi-customized, is it's much easier to scale in terms of the manufacturing. So it means that if we get to a point where we're able to kind of distribute this across NHS workers, it will enable us to more quickly turn around masks that we hope will still provide a much better fit and better comfort to the user, but also to get to that person very rapidly, to make sure that they're safe and able to do their jobs. The other thing to mention is that our design is novel in the sense that it has two key components to it. So as well as having kind of a rigid shell to the mask that is customized, we're also introducing an interface that sits between the mask and the facial profile, which is made of silicone. And what we're using is a medical grade silicone material that is actually very moldable to the face. And that's really what is offering us quite significant improvements in comfort when wearing the mask that we're prototyping and designing at the moment. So it's really exciting because we've had a lot of really positive feedback from clinicians. We're working very closely with some collaborators at King's College, and they've been receiving really positive feedback, and equally so here in Birmingham with a number of the hospitals. So for me, it's a really exciting project at a very rapid development phase. We're now starting to reach out more closely to industrial partners to think about follow-on steps once we're kind of happy and validated our design. How do we get this out to distribution quickly? How do we ensure that the manufacture is of an appropriate cost? And wherever possible, we're looking to try and do that with businesses based within the UK, such that we can, as a nation, develop more of a joined up manufacturing network, which offers us an improvement in our resilience to potential future healthcare crises as well.
Thank you for that answer. It's really interesting, the work you're doing. I'm just personally interested, is so I understand the surgical masks are single use. Is that the same for the masks that you're developing, or are they reusable, washable?
Yes, that's a really good question. Thanks for bringing that up. So yeah, what we're aiming to do with our design is for it to be reusable. So the idea of having that enhanced comfort and obviously that customization, not being able to use that mask more than once, probably makes a fully customized mask not cost efficient unless you're reusing it, really. So we're doing quite a lot of work to look at not just the design itself, but also the maintaining the quality of the design over periods of time, because it will be reusable, but of course it will need to be sterilized or disinfected between uses, and therefore it's really important that all of the materials that we select for our design are resistant to any of those disinfection processes. So yeah, that's a really good point, Carter. Thanks for bringing it up.
Brilliant, thank you. And finally, I'm about to go into my final year studying mechanical engineering. Do you have any advice on how I can shape my future at this stage of my university experience?
So I think for me, one of the pieces of advice that always has remained at the forefront of my mind comes from my father, actually. And he's always said to me, it's not just what you know, it's also who you know. And I think the world is about people. It's about connecting with people. And one thing that I always try and have in my mindset is that you can learn something from everybody in life. And I think if you really go through your degree and being open to learning from any opportunity, every opportunity, also just, you know, sometimes taking a chance and reaching out and trying to create opportunities for yourself. Perhaps that might be talking to a lecturer at the end to ask some extra questions, or to learn a little bit more about how what you're being taught maybe relates to some of their own research projects or work that they're maybe doing with industrial partners. you never know where those conversations might lead. For example, we've had with students on our course that have been really interested in our research, and then they've done summer placements with us, and we've been able to connect them to some of our collaborators, whether that be at other academic institutions or whether that be industrial partners. So I think, you know, Birmingham really is a fantastic place that has a very close-knit staff, student environment and community. And I would really advocate that you try and utilize the connections that are available through whether it be members of staff or whether it be through joining students societies or sports, if that's kind of your cup of tea. So yeah, for me, my attitude is always try and learn something from everybody, and really focus on the whole journey, and not just kind of the short-term outcomes, really.
Yeah, I think this time of lockdown's made me really realise the value I have of people and how much I miss talking to people and interacting with them. Yes, that concludes today's interview. Thank you so much for taking the time to talk to us today, Sophie. It's been really interesting hearing about your research and the impact it has on society.
Cool, thanks, Carter.